My dear students, welcome back to the lectures of formal languages and automata theory. In this video lecture, we are going to discuss about universal Turing machine. So, we will now understand what is universal Turing machine. And before we understand universal Turing machine, we must understand what is a Turing machine. We have seen in the earlier classes. So, as I told you in the previous discussions, our Turing machine is similar to our real computer, but the only thing is Turing machine will perform only a particular task. Suppose if we design a Turing machine for addition of numbers, for addition of the given numbers, so that particular Turing machine will work only for performing addition operation. Let us consider, we are going to design a Turing machine which can perform multiplication operation. So that will only perform, that will be restricted, and the Turing machine will only perform multiplication operation. Like that, a Turing machine can be designed only to perform a particular task. But to design a universal Turing machine, what we need to do? We need to combine, or we need to integrate all the programs. We need to integrate all the programs of Turing machines. We suppose if we want to design a calculator, we need to combine. We need to take the Turing machine program of addition operation. We need to take the Turing machine program for subtraction, multiplication, division. After combining all these things, we can say that machine is called universal Turing machine. The only difference between a Turing machine and universal Turing machine is a Turing machine can perform only a particular task, but universal Turing machine behaves like our digital computer. It performs several operations. It is similar to our digital computer. That's why we told that universal Turing machine, a Turing machine is said to be universal Turing machine if it simulates the behavior of a digital computer. So when do we say a Turing machine is a universal Turing machine? When it shows the behavior of a digital computer, we can say that machine is called universal Turing machine. So what does our digital computer will do? We have compared our universal Turing machine with our digital computer, right? We compared our universal Turing machine with our digital computer. So what our digital computer will do, our computer will take the input, process that input, and finally it gives output to the user. Similarly, our Turing machine will also do the same thing. Universal Turing machine, both Turing machine will also do the same thing. There is no difference between a computer and a universal Turing machine. Universal Turing machine will take the input, process the input, and gives output to the user. Similarly, computer will also do the same thing, as we know that. So the thing is that we can compare universal Turing machine with our digital computer. So a Turing machine, if a Turing machine is called as universal Turing machine, if it simulates the behavior of a digital computer. That's a very important point you must understand. And you all know what is a digital computer, which takes the input, processes the input, and gives output to the user. Then, what are the steps we need to take while designing a universal Turing machine? We'll understand now. So these are the possible steps we need to take for designing a universal Turing machine. Suppose if it is a normal Turing machine, we will have only one read or write head. We will have only one input tape, only one dimensional. We will have only one stack, and everything is a single thing only. So normal Turing machine consists of only one input tape, only one read or write head, and if you see, we will also move from left to right like that, or either actually in Turing machine, scanning process will takes from left to right or right to left. But the thing is, if I want to design a universal Turing machine, what I need to do is I need to increase the number of read or write heads. Why? Because number of input tapes requires more number of input tapes are required. That's why we need to increase the number of input tapes. Read or write heads we need to increase, and we need to go for dimension of the moving reader write head. Normal Turing machine will take only left right scanning, right, left right dimensions. It can move only left side or right side. But in the universal Turing machine, if it moves only to the left side or right side, then sometimes it is difficult to design a universal Turing machine. That's why we should also increase the dimension of moving the reader right head. That is also the requirement, and adding a special purpose memory like stack. So we need to add some more memory like stack. So these are all the requirements. These are the basic requirements we need for designing a universal Turing machine. And remaining thing, everything is everything same, which is normal to our Turing machine. So this is the basic difference between normal Turing machine and universal Turing machine. So I told you that Turing machine is designed to execute only one program. Turing machine is designed to execute only one program. If I design a Turing machine to perform addition operation, the Turing machine is restricted and to execute only that program. That will execute only that single program. It cannot go for any other operations. So, but real computers, we know real computers are reprogrammable. We can add any number of programs to the computer. If we add one more application to the computer, if we install one more application, any application into your computer, that application will also work. So we can compare universal Turing machine with our real computer. But Turing machine is not like the Turing machine. It also behaves like a real computer, but it executes only single program. That's why we are unable to compare this with our real computer, this thing. So perfect example for universal Turing machine is our normal computer. We can go for that. And these are the basic requirements for designing a universal Turing machine. We need to go for, and see here, the very simple statement is given. How to design a universal Turing machine? Answer is to add all the Turing machines designed for each separate task. So we have designed Turing machines for separate tasks. Consider you design a Turing machine for addition, subtraction, multiplication. After integrating all of them, after integrating all the programs, we can call that as universal Turing machine. That is the point which is given here. And these are the basic requirements for universal Turing machine. So this is what I would like to explain you. I would like to teach you regarding universal Turing machine. Thank you. We'll meet in the next video lecture.